everybody, this is Dr. O and welcome to Balancing Chemical Equations. In this video, we're going to learn my easy rules for balancing chemical equations and then road test these rules by working a couple of problems. So let's first take a look at these rules. Rule number one is to write a basic equation with the correct formula for your reactants and your products, which means that you must know that you have the correct formulas for your reactants and your products. We don't go into that in this video. We're just simply going to look at an equation and balance it. Rule number two is to balance the elements that appear in both a reactant and product first. Now, if you don't have this sort of scenario in your equation, then you would start by balancing metals followed by nonmetals. Rule number three is to then balance elements or diatomic molecules. Now, it might seem that it would be easier to start with those, but in fact, it's not. You really want to work with these last. Rule number four. If balancing requires that one or more of your coefficients be a fraction, which does happen on occasion, now is the time to address those by multiplying the entire equation by a factor that will eliminate that fraction coefficient. And this is typically going to be whatever number is in the denominator of that fraction coefficient. And rule number five is to check your work to ensure that the equation is balanced, which means that you have in fact followed the law of conservation of mass. These are the rules. So now let's take a look at some problems. All right, we have example number one, and rule number one would have us write a basic equation, so let's do that. Here we have aluminum reacting with sulfuric acid, and that's going to yield aluminum sulfate and hydrogen. Now, before we write this equation, we need to make sure that our compounds formulae are balanced, and here I've done that for you. And of course, you can always check my work, and you may have to do that on your own, and that will be covered in another video, not here. We're simply going to balance the equation. Now, rule number two has us start balancing this equation by looking for elements that appear in both a reactant and a product. For this equation, that's going to be the polyatomic ion sulfate. As a reactant, we have one sulfate ion, but as a product, we have three sulfate ions, and we know that by this subscript right there. So we're going to have to find a way to increase the sulfate ions in the reactants. And that's going to be done by altering the coefficient. Now, we never alter subscripts when balancing these equations. We only address this in balance through the coefficients. So, to achieve 3 sulfates to the left of the arrow, we're going to place a 3 in the coefficient space for sulfuric acid. And that's going to balance the sulfate. But it's going to change the number of hydrogens, so we're going to need to be sure to look at that in just a minute. But for now, we have satisfied rule number two. Rule number three has us balance elements or diatomic molecules next. Now we can deal with those hydrogens, and we have hydrogens here and here. Now, as a reactant, we placed a 3 in front of sulfuric acid to balance those sulfate ions, which means that we also changed the number of hydrogens in the reactant. Now, before we tripled the number of sulfuric molecules, we had 2 hydrogen atoms, but now we have 6. And we can determine this by multiplying the coefficient by the subscript for hydrogen, which is going to be 3 times 2, and that equals 6. So I'm going to need to have 6 hydrogens in the product. Right now I have only 2, but this is easily increased to 6 by putting a 3 in its coefficient in that hydrogen diatomic molecule in the product. And this is going to give us 6 hydrogens. The coefficient of 3 times the subscript of 2 equals 6, and with that we have balanced the hydrogen. Now what's left is aluminum. And if we take a quick look, we can see there's 1 aluminum in the reactants, but there are 2 in the product. Fortunately, this is a really easy fix. We simply need to double the aluminum in the reactant, and we do that by giving it a coefficient of 2. Now that we've looked at all the players in this equation, let's move on to rule number 4. Now, if we balanced our equation by using fractions in our coefficients, at this point we'd want to eliminate those fractions by multiplying the entire equation by what's in the denominator. Now we don't have any in this equation, so we're just going to move on to rule number 5. Now we need to do a quick check to make sure we've accounted for all of our elements on both sides of the equation. And the elements involved are going to be aluminum, hydrogen, and that sulfate ion. So for aluminum, it has a coefficient of 2 and a subscript of 1, and we multiply those and we get 2, so we have 2 aluminum atoms. For hydrogen, it has a coefficient of 3 and a subscript of 2, which gives us 6 hydrogen atoms, and for sulfate, we have a coefficient of 3 and a subscript of 1, giving us a total of 3 sulfate ions. So these are the elements in the reactants. Now for the products, for aluminum, it has a coefficient of 1 and a subscript of 2, which gives us 2 aluminum atoms. For hydrogen, a coefficient of 3 and subscript of 2, which gives us 6 hydrogen atoms. And for sulfate, we have a coefficient of 1 and a subscript of 3, giving us a total of 3 sulfate ions. So these are the elements in the products. And if we compare our results, we see that the numbers are the same side to side. That is, we have the same number of each type of element on both sides of the equation. And that means we have successfully balanced our chemical equation. Here we have our second example, and rule number 1 is going to have us write a basic equation, so let's do that. And we have water reacting with oxygen, and that's going to yield hydrogen peroxide. And with that, we're done with rule number 1. Now, rule number 2 has us start balancing this equation by looking for elements that appear in both a reactant and a product. For this equation, that's going to be the hydrogen. And as we can see, they're balanced. We have two hydrogens in the reactant and 2 in the product, so we're done with that. And let's move on to rule number 3. So rule number 3, we're dealing with those single elements and diatomic molecules. And here we have oxygen in 2 places on the reactant side and 1 place in the product. Now, water has 1 oxygen, and there are 2 oxygens in our molecule of oxygen. And then we're going to have 2 oxygens in our product. So for our reactants, we're going to have a total of 3 oxygens, and we're going to have that 2 in the product. Now, to balance this, we could try using coefficients like we did with the previous example, but we would alter the hydrogens and cause an imbalance. So this really isn't going to work in this problem. We're going to need to come up with a different approach in order to make this problem balance out. So because we can't put a coefficient in front of either one of the molecules with a hydrogen in it to get to our solution, the last place we have to look is to that diatomic oxygen. Now, it would be perfect if we had only one of those because that would balance our equation. So is there a way that we can achieve that? Hey, what if we cut that number in half, like gave it a fraction coefficient, like 1/2? That would work. So by having only one of those oxygens in the O2, we basically divided it in half by putting that 1/2 as a coefficient. We can now say that we have 2 oxygens in our reactants, and that balances out our equation. So great. Let's move on to the next rule. Now, rule number 4 asks us to eliminate those fractions in our coefficients, and we're going to do that by multiplying this entire equation by whatever number is in the denominator of the coefficient fraction. And in our case, that's going to be 2. So we're going to multiply our chemical equation, all the coefficients in our chemical equation by 2. So let's go ahead and do that. Multiplying everything by 2 is going to give us 2 water molecules. And here, if we multiply that 1/2 coefficient by 2, it'll give us 1. And I'm not going to write that coefficient in. It is implied by virtue of the fact that we have the O2 present. And lastly, it'll give us 2 hydrogen peroxide molecules. And with that, we're done with rule number 4. And rule number 5 is to double check our work. So let's bring up our elements, and we're going to multiply coefficients and subscripts for hydrogen, and we're going to get a total of 4 hydrogens in the reactants. And for oxygen, this is held in 2 places in the reactant, so multiplying the coefficients and subscripts for each of those places gives us a total of 4 oxygens. Now let's check against what we have in the products, and multiplying coefficients and subscripts for hydrogen, we get a total of 4 hydrogens. And multiplying coefficients and subscripts for oxygen, we get a total of 4 oxygens. And when we compare the 2 sides, we can see that we have the same number of elements on both sides, which means we have balanced our chemical equation. Good job. Once more, here are my rules for balancing chemical equations. If you found this video helpful, give it a like and hit that notification bell. If there's a topic you'd like me to do a video on, leave that in the comments below. And as always, do really well on your next exam. Thanks for watching.